In the earlier class, what we saw? Vector product, right? So we saw when we saw what will happen to the multiplication of two vectors, correct? So we said multiplication of two vector can be a scalar or a vector, and we saw the first one when the multiplication of a vector is a scalar, and you call that as a scalar product or dot product. Okay, so and dot product is a scalar and the magnitude will be what? So if you have a vector dot b vector, this will be equal to what? Magnitude of a into magnitude of b into cos theta. Okay. So we also saw what is this cos theta. So theta is the angle between the two vectors. If you see here, so it is something like what you have. So let this be a vector, this be b vector, and if this angle theta, so then this is the component of b along this will be b cos theta. Correct? Can you tell what is the component of b perpendicular to a?
90 degrees.
Component of b.
Cos 90 degrees.
No, how do you get a component of b here? What is the component of b here? That is b cos theta along a. What will be along? We did na. That's for the
B sin theta.
yes, b sin theta. You remember resolving the vectors? We saw na. How do you resolve the vector? Given a vector, if this is the axis x and y, and if this is the vector, say something like a vector or something, so its component along, if this is the angle theta, so this will be a cos theta into I cap, and this along this will be a sin theta into j cap. Correct? Because that's simple, because opposite cos theta, because this is what? This length is a cos theta, correct? And this length is a sin theta. Okay, so this length I am saying. Okay, so you know that, right? You remember that. So this is this length. That is a cos theta. And this length is a sin theta. And that is the magnitude of it. Okay, so if you compare with this, so the component of b along a will be similar, na? So b cos theta, and the b along this perpendicular vector y, or we don't know why, I am just drawing a perpendicular vector. So that will be what? B sin theta. B sin theta. That will be a vector along this direction, the component along this direction and this direction. That will be the magnitude. Okay, fine. This is what, anyway, in the dot product, so it is a b cos theta. That means you are multiplying the magnitude of the vector along the other vector, or the magnitude of the vector along the. So what you do, you are trying to bring both the directions same. Get b also along a. So you have to find out the component of b which will fall along a. That is b cos theta, and multiply the magnitudes b cos theta into a. So a b cos theta. Or other way you can do it like this way also. The component of a along b, that's also a cos theta. That into a b cos theta. Fine, and this is what we saw about the dot product. Okay, and in physics, we saw the example also, right? One of the very simple example is what? The work done. You remember? Work done will be what? Work done is a vector. Work done is a vector. Work done have a direction? Then you should have asking, na? Scalar. So work done is what? F dot S. Correct? Where F is a vector and S is a vector. So of course this is what example in the physics where you have scalar product of vectors. Okay, then many things will come later on when you do that. You will find it later on in higher classes when you go. You will find there are many scalar products has to be multiplied to form a vector quantities. So many product of vector quantities has to be multiplied such that you should get a scalar quantity. So you will find out this dot product. Lot many things in the later on in your higher studies you will see. Okay. And so, and this is very interesting. So what happened, there is one example in your book. So that's also easy. Simple example in your book is what happened. Suppose if you have a cart with a wheel. Okay. And if there is a rope, you are going to pull this rope in a certain angle F, direction F. So when you pull, what happens? So this is the road or the platform, whatever you call. This is the platform in nature. So when you pull it like this, so when you are going to pull the cart like this, so what happens? The cart will move, correct? The cart will move towards this direction. Okay, so it will have, suppose the cart, when you move that, the cart has moved to this direction. Okay, the cart. So this is the distances. Am I right? So this gives you the distance S. S is a vector because moving in this direction. Okay, and the force, where is the force? Force is a vector. Force is in this direction. Now what is the work done? Okay, so of course the work done is not this F into S. You can't do, because see, all the force, see, when you pull like this, you need more force. On the other hand, if I pull the rope like this, then with a less force I can pull. Correct? So therefore what happened? What going to account for what is going to make this cart move is the component of force which is along the displacement. Am I right? So what you have, and if you are pulling this at an angle theta, so then the component of force F along this direction is going to be what? F cos theta. Okay, and the direction will be the same direction. So the work done will be what? F dot S. Correct? So that will be what work done will be F magnitude of F magnitude of S into cos theta. You got it? Because it's F dot S. Normally we never bothered about cos theta because all along when we are doing, we have applied the force in the same direction of the displacement. Okay, there are many things will come up. There are many cases. You can equally think of many other problems also. See, for example, I can simply tell you one simple experiment kind of thing which you can do. So you have a toy car. You have a toy car in a platform. Okay, so this platform is hinged here. Okay, let me draw it neat. So it's a rough surface. We are having a rough surface. Okay, and that is a platform which is hinged at one point, so you can lift it. And now if you have a small car, okay, and the surface is rough, and suppose the wheels are made up of rubber, so there is a friction, correct? So when you raise it, when I raise it slightly a bit above, so what happened? The car will, when I raise a large, the car will roll down. Okay, and when I raise a little bit, will the car roll down? Slowly, it may not even. Sometimes if it is, the friction is there, na? So the car will not. So what happens? So if I start, so I'll start the platform like this, I'll raise the platform like this, small angle theta, so the car may not roll down. Okay, it will stand. So then when I raise it further of this angle theta, then the car will start rolling down. Am I right? It will start rolling down. Okay. So, and if you see, you are not doing nothing. All you are doing is just depending upon what is the angle of the platform, some work is being done. Okay. So when your angle is smaller, there is no work done. When angle is larger, the work is being done. Why? Because your friction, so the friction will not let the car to move down. Okay, so the friction will give you something what they call, okay, So then, okay, what is the force which is going to act here? That's a gravity. Okay, so what is the gravitational force? When it gravitational force always perpendicular to it. That be what? mg. Am I right? So then you have, there is a force mg. What will be the component of this force along this direction? Can you identify? So if I say this angle is theta.
So MC.
Yeah. So yes. So what up? No. See, say what will be this angle? 90 degree. Okay. So this is theta. So this will be what?
90 minus theta.
90 minus theta. Okay. So this will be the component of force acting downwards. That will be what? F equal to mg into, okay, F is a vector. The magnitude of F, I wouldn't say F, magnitude of F will be mg into cos 90 minus theta. Correct? So, when the
Cos 90 minus theta is sin theta.
that's okay. That you can do. You can say. So, when I keep it down, when the theta, that means theta becomes 0. Correct? So, then what happened? Theta becomes 0. So, cos of 90. That will be what? 0. That means there will be no force which is going to pull the car down. So, now as I keep increasing the platform, slowly if I keep increasing the platform, then theta is not going to be 0. Theta is going to slightly become larger and larger. Okay. So, then it's going to move, become less than 90. As it becomes less than 90, cos will keep increasing. It becomes 0, it becomes 1. So, at some point, this force component will come up and the car will roll down. You can overcome the friction of the platform and it will roll down. Okay, so this is way. So, that's what I am saying is, so the component in the physics, what happened when you have a vector, what important is often is not what the vector. The component of the vector along the direction which is I wanted to use in my calculation. Okay, the vector can be any direction, but I may need to find out the component of the vector along certain other vector, or maybe my x-axis, y-axis, z-axis. So so that's what. So that component of the vector. Okay, so that's how this component of vector will come out. And where the dot product comes is, so in a dot product, what matters is the component of vector along that direction. That's what we are doing it here. Okay, so this is a simple example of, this is an example for scalar product, and this is an example of how this vector components matter in physics. Okay, so now let us, okay, this is a simple, so this was what we did is a scalar product. Okay, so now let us go for the next vector multiplication. That is what, when you multiply two vectors, okay, you should get a resultant should be another vector. That you call it as vector product or scalar product, cross product. Okay, so vector product, or you call as cross product. Okay, and what it says is, if you have a vector A and another vector B, the cross product of these two vectors is A vector cross B vector will be equal to magnitude of A into magnitude of B into sine theta, where theta is angle between the two vectors, and this is finally a vector. Okay, so I will call that as some unit vector direction, UR cap. Okay, and where UR cap will be perpendicular to A vector and B vector.
How can it be perpendicular to both?
Of course, I have two vectors. Can't you have a vector which is perpendicular to both? What about this vector?
Will be straighter.
No, a vector coming out of the board.
Oh.
Correct? So 3 dimension, you are not living in a 2 dimension. So the vector coming out of both is perpendicular to both the vectors. You got it? So this is what, and why this is what happens. In a vector product, always you get in physics, the cross product when you want to multiply 2 vectors to form a vector, the resultant vector will be always perpendicular to both the vectors. And one example is what I gave you yesterday is a Fleming's left hand rule. Okay, what is that? This is a motion. One is I guess this is a magnetic field. If you see what you studied in your 10th standard, what is that? Fleming's left hand rule, which is the field, current and direction.
First finger is the field.
Okay.
Motion is the
Thumb, and this is the direction of the current. Correct. So what happened? You can see when there is a current carrying conductor placed on a magnetic field, it's going to face a force, okay, which will be perpendicular to the direction of the current as well as the magnetic field. Okay, so that's why your vector product comes. If you represent magnetic field as B and this force, okay, so what it says is, what you will find is, so if this is the field B and if this is the direction of current I, okay, and what will the Fleming's left hand rule says, so this is the direction of the current, so this is the field, so this will be the motion upwards, right? So the motion, this will be typically the product of these two. Okay, so the force or whatever it's going to act perpendicular to that will be, I can write it as LB vector. I'm not going to write what is the exact formula and all. This will be proportional to I vector cross B vector, or either of the variables. You can take the minus in whatever it is. Okay, so this is where one of the, yeah, correct. So there will be so it typically you can find out, will it be, yeah, you can write it like that. Fine. So, so this is not exact formula. In exact formula, it will be velocity of the charge into the B. Okay, here I am writing in terms of current, but when we later on classes you will understand what the exact formula of force acting when electron or current is moving. Okay, so this is a simple way I am writing it out. So this is one of the case where you have in physics what you see, 2 vectors are multiplied to form a third vector, and the third vector will be always perpendicular to the 2 vectors. Okay, so this is how a vector product is introduced in physics. Okay, so and if you can see here, if you remember this one, I think interesting. So there we had cos theta, here we have sin theta. So which component we are taking?
Y.
Yes, correct. So what happened? So not y, perpendicular component. Okay, so for example, so if I have, this is my vector A, and if this is my vector B, and if this is the angle theta, in a dot product what we did, we took the component of B along A. Now you take the component of B perpendicular to A. That means it will be like this, correct? So this will be B, what do you call? B sin theta will be the magnitude. So it doesn't have an direction. So, and what will be the resultant vector direction? Will be perpendicular. Correct? Maybe this way, outwards or inwards. We will see which direction. There is a rule. We will see. So it's perpendicular to this. Okay, so what happened? So what you are saying? So now what you have done, any vector, cross product of vector, A cross B or B cross A, whatever you say. So A cross B or B cross A is a vector which is perpendicular to both the vectors. Okay, and the magnitude will be the perpendicular component of these 2 vectors. See, now this and this are perpendicular. Take the perpendicular. So there should be all mutually perpendicular vectors, kind of. So you multiply the magnitude which is perpendicular to each other, and then that is the magnitude of the vector which is a cross product coming out or down. Now what is the direction? When I say it's perpendicular, you can have it outside or inwards also. Okay, so that's what you call as a right thumb rule. So what in right thumb rule it says is, hold your vector like this. So this is your curved fingers that says from where to where you are going, and thumb shows the direction. Suppose that means what? So I am having a two vector. Let us call this as A vector, and this is the B vector. So, and if you ask me what is A vector cross B vector, the direction will be, so you are taking A vector to B vector. So go from A to B. Okay, and hold it like this. So this is the fingers, you take it as an arrow. This goes from A to B. Okay, and where the thumb comes up, that's what your resultant direction. Okay, and now you tell me what should be B vector cross A vector. Yes, like this, because B is above now. This curled finger should go from B to A now. So the vector direction is inwards. Now you tell me, so the vector cross product is commutative or not? Is it commutative? A cross B is equal to B cross A? Okay, the magnitude is same, but the sign is opposite. Okay, A cross B will be minus of B cross A. Okay, so you have to make it like a negative vector. Okay, so this is what your cross product of vector is, this one. Okay, you call the vector product obeys distributive law of multiplication. So what does the distributive law of multiplication? So A vector cross B vector plus C vector will be equal to A vector cross B vector plus A vector cross C vector. We will not go into the proof of it. Proof is slightly how to take a different components and we can prove it. That will some other time, if I made later on classes, you will be able to prove it. Just only thing you remember, vector product follows distributive law of multiplication. Okay, you can prove it by taking the components in xy, break the vector into x, y, z component, and then you will see right hand side and left hand side comes out to be same. You understand? A vector you can resolve into three components: ax by ax I cap plus ay j cap plus az k cap. So similarly you can do. Okay, then I will show how your vector product comes when you take a cross component wise. Like earlier we did for dot product. We'll do, so you have to use that property and you can prove this both are right hand side and left hand side will be same. Okay, which is not there in your book, I am leaving it. Okay, so and that's all. And the other one interesting property is special cases of the cross product. So that is, we saw there also, right? So when the theta becomes 0. Okay, tell me what happens. So A cross B will be equal to A B sine theta. So when theta equal to 0, what happens A cross B? To 0. Correct? That's right. Why? I told you. So you are having theta equal to 0 means your A vector and the B vector are in the same direction. What in a cross product we do? We take the perpendicular component of the B vector, the magnitude of the B vector, and then take the multiplied the magnitude and put a direction along perpendicular to both. Now what is the component perpendicular to this vector? 0. Because there's no, because along this vector, na? 0. So naturally it becomes 0. Okay. And tell me other angles. What happened when it equal 90 degree? A vector cross B vector. Yeah, I forgot to write down the direction. This is wrong. What you have to write is, this is a scalar, this is a vector product, and this is a vector. So I call it as a UR cap. So that is a direction which is perpendicular to A and B. Okay, and what is the direction? Use a right thumb rule.
But in that case, there will be two directions which are perpendicular to A and B, right?
Correct. But which direction you have to take?
Okay, the output.
Right thumb rule, na? A cross B. So one direction is A cross B, another direction is B cross A. So two directions you'll have. Got it clear? So now, tell me when theta equal 90 degree, what this will be? This will be
Magnitude of A magnitude.
into U R cap. Correct. So this is what, when theta is 90 degree, the vector is just the product of the magnitudes direction. Okay, this is the maximum case when they all are three are perpendicular to each other. Okay, so that's the saying. What you are in a vector product, resolve the vectors into, you are given two vectors, resolve the vector into perpendicular vectors. That's why we are taking one as a sin theta. Okay, and then multiply them both the magnitudes and take a direction perpendicular to it. Okay, now when I give both the vectors, already they are perpendicular to each other. Life is simple, just multiply the magnitudes. So that is the maximum we are getting. You got it? 90 degree. And what they have, you can do it for 180 degree also. Tell me what will be 180 degree? That also same thing, na? When theta equal to 180 degree, what happens? Sin 180 degree is 0. And that's true. Because you have one vector like this. You have one vector A like this and another vector B like this, for example. Okay, so what first you have to do, you have to resolve one vector to perpendicular to the other vector. So basically you want to create a vector which is perpendicular. What is the perpendicular component of A?
A sin theta.
What is the theta here? 90 degree. So what A sin theta will be? 0. So you can't have a perpendicular component. If B sin theta also will be 0. Therefore, whenever you have this vectors are parallel or anti-parallel, the cross product will be always equal to 0. Okay, you should remember that. And okay, this is very interesting. So then what happened? Now, so now these are all vectors of different magnitudes A and B and all. Let us do the same thing with unit vectors along XYZ direction. What is that? I cap, J cap and K cap. Okay, tell me what should be your I cap cross J cap? Correct, of course, it will be 90 degree.
1.
Huh?
1.
Magnitude is 1. Tell me the direction. What happened? You are having I cap and this is what?
J cap.
J cap. Okay. So of course, when they are 90 degree, just the product of 90 degree, the magnitude, just the product of both the vector magnitudes. They both are 1, so 1 into 1. So 1. So what will be the direction? It will be perpendicular to these two? Okay, so its magnitude is 1. You are right. Correct. So let me write down its magnitude. So the magnitude is 1. Now give me the direction.
Direction will depend if it's from I to J.
Of course. What have you written? I cross J.
So then will be like
Right thumb rule.
outwards.
Correct. Outwards. What is outward? What is the axis outwards?
K. No,
Correct. You are right. K. Because if it is X, if it is Y, Z is perpendicular to it. Right? So what this will be? K cap. Am I right? Because that's what a coordinate system is. X and Y are perpendicular and Z is perpendicular to X and Y. All three vectors are perpendicular to each other. Okay. So now, so this is what? So 1K, you can simply write it as K. So I cross J is equal to K. Now can you tell me what will be J cross I?
minus K.
Yes, very good. Correct. This is minus K because opposite negative vector. Okay. And tell me what is J cross K?
J cross K.
I. What about I? J cross K will be? Tell me which I it is?
Positive.
Yes, because this is K. Let us put it as K. So j cross k, that means j to k, correct? So you have to curl like this. This is the positive direction, right? So this will be your I cap.
No, it should be actually minus I because J to K. So it will be like this.
K is here, na? K is this direction. Okay, so put it. So j to k, na? So right hand thumb rule, j.
Okay.
This is k to j.
Oh, okay.
So okay, so this is what you're doing. J to k, na? J cross k. So this will be I. Okay, so similarly you can keep on doing for so k, okay, I can write k cap, so this is I. K cap cross j cap will be equal to minus I cap. And what is the last one left over? Tell me. I cross k, correct? So I cap cross k cap will be what? Tell me. So keep them. So I is here, k is here.
Minus J.
So yes, so what happened? So this is what I am doing. I cross, okay, I to k I am coming. So this will be minus j vector, j cap, or k vector k cap cross I will be equal to j cap. So you should remember. So this is what important, and when it is a unit vector, you have to know it, okay? Because they all are perpendicular to each other. So this is how.
J cap.
Now tell me,
J cap. No.
okay, so if I give you two equal vectors, two vectors are equal. What am I going to say? Let me say A vector is equal to B vector. So when you say two vectors are equal, they both are equal in magnitude as well as the direction also. Okay, so when they both are same direction, so what will be A cross B?
It will be 0.
Correct, 0, because what will be now? A, B, sine theta. So when the vectors are equal, what is the theta? 0. Okay, so this becomes 0. Theta is 0, sine 0 equal to 0. This becomes 0. So this is what? Equal vectors. So now when you multiply equal vectors, of course, then they become 0. Same direction. What I am saying is, everything is simple. In a cross product, you have to, for cross product between any two vectors, resolve them into perpendicular vectors. The moment when they both are having same direction or anti-parallel direction. Theta equals 0 degree or 180 degree, the perpendicular component of either of the vectors is going to be 0. Okay, so naturally, so whenever two vectors, they are parallel or anti-parallel, the cross product is going to be 0 only. Okay, so okay, now when you know this, tell me what will be this? Tell me now what will be I cap cross I cap? Yes, 0. Okay, so I cap cross I equal to 0, or you can just simply write 0. Similarly, j cap cross j cap is also 0, k cap cross k cap is also 0, because they all are same direction. Okay, or even though if you have minus I cap cross I, that is also equal to 0, that is anti-parallel. Okay, so now, so this is how the vector product is, vector product of these unit vectors is being defined. Okay, so now let us do another, okay, given a vector A and B, and if you, there's a two vector given A and B, and I want you to do the cross product as its components. You resolve them into rectangular components, XYZ components. When you resolve them, how the vector product will be looking like? That's the question. Okay, so what happens? Oh, correct. We are having here. So we having two vectors A and B. So we want to find out the product, that is A vector cross B vector, and we want to see, so this product is going to be a vector. What will be the component of this product along x-axis, y-axis and z-axis? Okay, so then what happens if you put up the questions? What happens? So you have a vector A, vector B, the cross product is going to be a vector. We saw that. Okay. Now I think what is the resultant vector? The product of that vector. What will be its components along x, y, z? How to do it? First resolve AB into 3 components, rectangular components. So what are you going to do? So let our A vector be AX I cap plus AY J cap plus AZ K cap. Tell me, what about B vector? I cap plus BY J cap plus BZ K cap. So what we want to do? A vector cross B vector. That will be equal to A vector is what? AX I cap plus AY J cap plus AZ K cap cross product of, okay, so cross product of BX I cap plus BY J cap plus BZ K cap. Okay, so now we know vector cross product follows the distributive law of multiplication, right? So we can write this as this into this, this into this, this into this, something like that. Same what we did. So what will happen? So AX, BX, I cap cross I cap plus AX, BY, I cap cross J cap. Tell me, then, oh, we removed all those things, huh? So we need that. Okay, and so what will be third one? AX, BZ into I cap cross K cap, and then plus AYBX, correct? AYBX J cap cross I cap plus AY BY J cap cross J cap plus AY BZ J cap cross K cap, correct? And the last one is AZ BX K cap I cap plus AZ BY J cap plus AZ BZ K cap. Okay, so we will write down that value. What is that we had? So we had this is your I cap, J cap, and the K cap is perpendicular, correct? So I cap dot cross J cap, that will be what? Like this. Okay, so that will be equal to K cap. So the reverse is negative. So J cap, okay, J cap cross K cap, right? So J cap cross I cap, J cap cross K cap will be equal to what? J is here, na? Like this. J to K, I cap. K cap cross I cap equal to K is what? Here. K cross I cap, right? Here. Like this. K to I, na? I cap will be J cap. So when you make it opposite, this is going to just change the sign. Okay. So now we also know I cross I equal to what? I cap cross I cap equal to J cap cross J cap equal to K cap cross K cap equal to 0. So since all these common guys are 0, okay, sorry, this is a cross product of the same vectors are going to be 0. So this will go off, correct? And this will go off, okay, and this will go off, correct? So now let us write down by the component wise. So so this will 0. So I cross J will be equal to what? Tell me. So AX BY I cross J is K cap. Am I right? So this will be what? K cap. And This is AX BZ, correct? Plus AX BZ. Tell me what it will be. I cross K.
Minus J.
Yeah, that is minus J. So I will write it as, let me write as minus here. Minus J cap. Correct? Because I cross K is K cross minus of K cross I. So it will be minus J. Tell me what about this?
Minus AYBX K cap.
Okay, minus AYBX K cap. That's right, right? J cross I, of course. J cross I will be. And tell me what about this one? J cross K is positive. Plus AY
BZ I cap.
I cap. Very good. Then, what about here left over? K cross I. K cross I is J cap, positive, correct? K cross I is J cap. So, AZ BX, correct? Plus AZ BX into J cap. Very good. Then, what about the last one? K cross J minus. Very good. So, what is the minus? Tell me AZ BY into I cap. So let me do one thing. This is one. Let me combine all the I terms together, J terms together and K terms together. K cap. So what it will become? Tell me. So our A cross B equal to, so let me combine the I cap. What are the I caps we have? This one and this one, right? So if I combine them both, what you have? AYBZ minus AZBY of I cap, and then let us try the K cap one. So K cap, what are the K caps? AXBY, correct?
We should go to J cap, right?
Oops, sorry, yeah, J cap only. Oh, I said K cap. Yeah, J cap is this one and this one.
AZBX.
Okay, so what you are going to write? Plus AZ BX
minus
AXBZ of J cap. What about the last term? Plus the last term is these two. AXBY
minus AYBX.
Where? AYBX.
Oh, that's plus.
Which is plus?
AY. Oh, it's minus.
Minus, na? These two, na? AXBY minus AYBX of K cap. So now, I can slightly do a little bit of jugglery. What am I going to do? I will take this minus commonly outside, the second term. Why am I going to do is, you will see. So then what happened? If I take minus commonly outside here, so what will become? Tell me. So let me write it down. The final expression, I am going to write it down in a different color. Because B vector will be AYBZ minus AZBY of I cap minus AXBZ minus AZBX of J cap plus AXBY minus AYBX of K cap. Can you see some pattern? Have you done anything of this sort in your mathematics class? Do you remember?
Cyclic.
No? Cyclic only. All right. But recently we have done something of this sort, where you have this two product comes and minus and the third product. Two quantity product minus multiplied by the first product. You don't remember? Yes, correct. Matrices only. What is that part? Determinants. You can write this as a determinant. Am I right? I write it as I cap, J cap, k cap, ax, ay, az, bx, by, bz. Isn't it the same? You got it? So the cross product of two vectors, if you want to resolve it, it's just nothing but a determinant. Okay, the three component determinants, you take it out, that's all the three directions. So the directions of your resultant product, when you resolve it along x, y, z, this is what? This is your x direction, this is your y direction, and this is your z direction. Now interestingly, you see, this will not have any x component at all. Because I cap x component, so x component automatically vanishes here. So always we'll take only the perpendicular components. Okay, so this is a very important rule in the cross product of two vectors. So this is how your when cross product of two vectors is defined, and this is all how we get components of these cross products along x, y, z axis. Okay, and now there is something in your book there's something what they call a parallelogram, area of a parallelogram. That's very simple actually. What happened? You see the magnitude of a cross product of two vectors. Let me do it here. Okay, we have this cross product of two vectors, right? So what they say, that's equivalent to the area of a parallelogram. When you construct the parallelogram as a sides or as a vectors. What is that I am saying is, if what happens, so we have A cross B, what we had A vector cross B vector, the magnitude of this vector is nothing but what? A vector magnitude, B vector magnitude into sine theta. Correct? That's what we did. I mean, all of you are doing that. So what it says is, so if you see this, okay, so if I try to write, okay, this is the A vector. Oh, sorry. Let me draw in a different color. So we are having, this is the A vector, and this is the B vector. Okay? So the magnitude is what? So if you construct a parallelogram, okay, where the length, see, this is the vectors are, this A represents the vector in direction as well as magnitude. B also defines means it represents the vector direction as well as the magnitude. The length is the magnitude. So when you do that, so the magnitude of this cross product is nothing but the area of this parallelogram. How to prove it? Simple. So you given a vector like this, if I give you this angle is theta, okay, so and if this is the height of the parallelogram, height, okay, let me call it as O. Okay, so the area of this parallelogram is what? Base into height. Am I right? So what is base? OA magnitude into height is h. Correct? So what will be the tell me. So what will be your height? So let me call this is B. So let me call it say something like C. Okay, and okay, so this is a right angle triangle. Okay, so OB, okay, well, tell me what is sine theta? Opposite side, that is H divided by OB.
So H is equals to OB sin theta.
H equal to OB sine theta. So you put up, so the area equal to what?
OA into OB.
OA vector into OB vector to sine theta. So OA is what? That's our A vector. So that is A vector into B vector into sine theta. And that's what? That is the magnitude of A cross B. You got it? These are all simple. So, and you have some of the exercises. So, you can do the exercises, I leave it to you. You try it by yourself, okay? They are very simple. You have to use only this, the products what we have used, the components what they are given, and the determinants, okay? Anyway, you have done it in mathematics, so this should be simple. There's something very interesting they given as a, what you called, as extra informations, do you know? Okay, and actually I think that's very interesting. You should know it also. Okay, so what is that is, see, what we are doing, we are actually trying to find out the work done. When you are applying a force on it, some work is done. When you apply a force on certain object, and if the object displaces, if that force is able to displace the object, so then you call the work is done on the object, right? There's a work done, you can do that. And so the displacement, it always doesn't mean you move the object. You could have rotated also. For example, you are having a screw. You are twisting the screw. There is the screw is there only, sitting there only, but it is rotated by an angle, correct? So there what happened, your angle, okay, there what happened, here you have the distance, there will be the angle, okay. So then when you say the distance traveled per second is called as the velocity. So displacement, what do you call? Velocity is what? Displacement by time. Displacement per second. Okay, that's velocity. Same way, when I spin it, for example, I am spinning a top. The top is going to be there only. It's not going to run around here and there. It will move slowly, but don't consider that. Okay. So suppose I am spinning the top is standing there still and it is spinning. Now there is something spinning there, right? I have to define, but here it is not a displacement, it is an angle. So now I can always say, what is the angle made per second? That's also speed, correct? So that you call as your angular speed. Okay, so what are angular speed, or what you call angular frequency? Okay, so what typically they call is the angular frequency, you can call angular velocity, sorry, angular speed, angular velocity. Okay, angular frequency is different. Okay, angular velocity is right. Frequency is number of rotations per second, but angular velocity is the theta. So what is that? What you are having is the angular velocity. So when you have this spinning, to define those spinning objects, where they are not linear motion, this is a linear motion. So this is a non-linear, it's a spinning. So there you should define a velocity there also. Okay, so that velocity is called as angular velocity. Will that be a vector? Tell me. Is theta is a vector? If you remember in the first class of mathematics, first lecture, we saw the directed angles. The angle also have a direction, correct? So of course, since angle have a direction, so then what is your angular velocity is also a vector, and that will be equal to theta made per second. Okay, what you had a normal velocity? Velocity is displacement by time. So you can see the equivalence here. You got it? Okay, good. So, and so this is very, why this is interesting is, so in fact you can connect these two velocities and all. Okay, so for example, let us take a spinning wheel. Okay, I am going to make a wheel. I am going to draw a wheel. What is the, I'll make a nice circular wheel. Okay, and let its radius, okay, let me make it as a wheel. Maybe a car wheel or whatever it is. So now this wheel is going to make a spin. What is going to happen? This wheel is going to spin. So it's going to have an angular velocity. Now I'm asking, so take for example, I'm going to asking you, so I'm fixing up a point or say I'm putting a sticker there. So this will have certain velocity v, right? At every time the velocity will be tangential. I'm asking, so can you tell me what is this velocity? I give you, what I can give you is I can give you its angular speed, omega, okay, and I can give you its radius, r. Radius is also a vector, correct, because it goes from center to, okay. So radius always goes from circle center to outwards. Therefore, radius is also a vector, okay. So, and now I will ask you, what should be your velocity? So here you will see the cross product. Okay, so I can tell you, I can simply write it, I will show you how it comes. V vector will be equal to R vector cross omega vector. Can you tell me why this is? Oh, sorry, in reverse. Omega vector cross R, otherwise V will be negative, sorry. Omega vector cross R vector. Tell me. You know how this is coming. Okay, let me tell you. So what am I going to do? So let me draw this wheel in my simplistic picture. So let me take out this point. So this is the center O, and this is the point I am making here, which is moving above like this. Am I right? So what is this distance? That is a radius r. Correct? So this distance is radius r. Okay. So now what omega is? Omega is the angle made in 1 second. Correct? So in angle made in 1 second, that is your omega. Correct? So this is a theta. I can call in 1 second. This is the angle made by the wheel in 1 second. So this is nothing but omega. Correct? So now what will be this distance? You know. Well, r omega. Correct? R omega. Am I right? R omega is a distance. So this is a distance travelled per second, because omega is the angle made per second. So this point is moved. This is the distance travelled per second. What is that? That's the velocity. So V will be equal to what? Typically the magnitude of V will be R omega. Okay. Okay, but only thing is, it is a magnitude, but it won't be R omega. There will be an angle also will come up. What I write? V equal to R omega. Okay. So here why it become R omega is, always omega will be perpendicular. Theta. Okay. Angle always when you write, you hold it like this. This is a, okay. So, and this is the angle direction. This is the R direction. So what will be omega cross R? Perpendicular to that, na? Correct? Huh? Omega cross R will be perpendicular to that, like this. So the phase vector will go like this. Clear? So, and only thing is, if it is not perpendicular, then the theta component will come up. So it is not spinning on a plane. It is spinning on a tilted plane, something like this. Okay, so you have axis like this. So if is rotating along this axis, then okay, they all are perpendicular, because radius and your spin axis is perpendicular. But now it is not spinning like this, it is spinning like this. Okay, so some of the radius with their different angles, if you have deformed way it's spinning. So then this angle information will come. Okay, so why I want to tell you this is also a cross product. What you are doing, we are calculating V, the velocity, which is a vector. That is due to the multiplication of angular velocity, which is a vector, and the radius, which is another vector. So this is also another example for a vector cross product. Okay, and how the product comes is like this, omega cross R. Okay, and there's one more thing they given, something which is, so as I told you, so we have a linear motion, when you have circular motion, so we have a theta. Same like force. When you push an object, give a force, object moves. And when you spin a top, it moves. Okay, so that's also something you are giving, force. Okay, what is the equivalent of force with here? What you call is a torque. Okay, that's what you call as when you give a force at a certain radius when you are giving. Okay, and that is what you call as a torque. What is that? Spelling is okay, symbol is tau usually. Is tau a vector? Tell me. Can torque be a vector? Of course, because I am going to spin. That has a direction, right? So of course this is also a vector. Okay, and what will be what is the magnitude of this torque is what will be its magnitude is torque should be so for example, let us give the spinning of this wheel only. Suppose I am going to spin it by the hand like this. Okay, so what am I going to do? So let me remove all these guys. All these things I am going to remove it. So we have this radius, of course, that's very good. We have the radius, and now I am going to spin the wheel. So that means what? I am going to give a force along some direction, which is spinning, correct? And the radius will be always perpendicular to it. So when I spin it, so you are going to get a torque. Torque is so what are things? How to do that? Yeah, I will tell you. I will show you. So the torque, what you have, torque is the equivalent of the force when you make a spin. I said the torque tau will be. I'll write the formula and I'll tell you how this comes in a real practically how it will look like. Tau will be r vector cross f vector. So the tau is, since I am giving a force along, okay, or something like that, you don't have to really spin. Put a wheel on a stick, axis, spin it. What do? You are giving a force. Okay, is that wheel moving in a straight direction? Am I right? When I fix a wheel on an axis and I'm going to spin it. So what am I going to do? I'm giving a force along a certain direction. But the torque is basically making it to spin. That is perpendicular to it. Okay, and now see what matters is it is not just the force. If I give it the radius, if it is smaller, the radius of the wheel is smaller and the radius of the wheel is larger, okay, the force I have to apply to make it to spin is going to be different. Do you know the reason why?
Smaller radius.
Yes. For example, I can tell you a simple example is, so you have a tap. You have seen the water tap. Am I right? So, water tap. And if you remember, the olden days water tap will have a knob something like this. Am I right? So, you open it, water flows, close it. What I ask you to, I will remove this top portion, okay, and I ask you to open. Okay, which is easier?
With the top.
Top is easier. Whatever, now when you open, I have to give a lot of force to open it, correct? The moment I keep increasing it, now it's easier. If I keep increase it further, just a small touch. Okay, so what happened? You can see it. So it is not just the force I am applying. It is the radius also comes into picture. Correct? So when I spin the wheel, the torque is not just the force. The radius. Am I spinning a smaller wheel? Smaller wheel is tough. You have to give harder. When I make a bigger wheel, it's easier. Okay. So that's what the torque. So torque will be a function of, will depend upon the force you are applying as well as the radius also. Okay, so therefore the torque is written as, therefore the torque will be always radius in cross product of radius into force. Okay, these are the other example of a cross products in physics. Okay, you can see, because these all are vectors I'm saying, am I right? Because when you spin a wheel, force you are giving, it have a direction. Radius have a direction. Okay, and it is spinning. The resultant torque is also there's a vertical, along the axis it has. So all the three are having a directions, and you see always they all will be perpendicular, mutually perpendicular. So all these things will come as a cross product. Okay, so this is what your vector cross product is. And a vector cross product comes up, a cross product of any two vectors is again a vector with a direction perpendicular to both the vectors. Okay, so how do you do the cross product? Take the component of one vector perpendicular to the other vector, and that magnitude will be the magnitude of the cross product, and the direction perpendicular to this, defined by your right thumb rule, will be the direction vector of the cross product. Okay, so and in entire physics you will find when the vectors, only these two products will be there in the in physics. You will, when it comes to vectors, only these two products is used in the vectors in physics. Okay, so and with that we will stop this vectors and the product of vectors, and we have some exercises. You have to do it by yourself, and in the next class we will see about calculus. Okay.